In this lesson, we will discuss place value and how your student can build upon previous place value knowledge. Place value is a crucial key to mathematics. Place value is the value of a digit based upon its place in a number. For instance, we classify digits into ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, and so on. In the number 14,592, the 9 represents the 10 place. 9 tens equals 90, so the value of the 9 is 90. Students work with numbers to the hundreds place in 2nd grade. No new place value is added in 3rd grade because the critical focus is multiplication. 3rd graders will still use place value understanding to add and subtract sums less than 1,000. This means that students add any two numbers together to total a number less than 1,000. An example could be 546 plus 314. Students will also subtract numbers less than 1,000 in 3rd grade. For example, 603 minus 478. In 4th grade, the emphasis shifts back to place value, and students extend their work to include whole numbers through 1 million, and they are introduced to decimals through hundreds. 4th graders explore fractions with 10 and 100 as denominators and are able to write them in decimal form. 5th grade then extends students' place value understanding by reading, writing, comparing, and rounding decimals to the thousands. Students in 5th grade will be given situations such as compare 47 and 65 hundredths to 47 and 56 hundredths, using greater than, less than, or equal to symbols. Students may be given numbers to round, such as 478 and 13 hundredths. For instance, if we were to round 478 and 13 hundredths to the ones place, we could list our benchmark numbers as 478 and 479. We would place where 478 and 13 hundredths is on the number line, noticing that it is closer to 478. Thus, it rounds to 478. Students extend their understanding of the relationship between adjacent places. If I had a 4 in the ones column, the value of the 4 would represent 4. If I move the 4 to the left one place, the 4 now represents 4 tenths. If I move it to the left again, the 4 represents 4 hundredths. And if I move it to the left once more, it represents 4 thousandths. Each time we move to the left, the value is 10 times larger than before. If I move the digit to the right, we would be decreasing the value 10 times rather than multiplying it. The power of the base 10 system is the repeated bundling and unbundling of 10. In 5th grade, the concept of 10 times as much extends the language of division to include 1/10 of. For example, 500 divided by 10 is 50, therefore 50 is 1/10 of 500, or 400 is 1/10 of 4,000. 5th grade students are able to see the beauty of place value in the base 10 system. A new concept for 5th grade is that students use whole number exponents to denote powers of 10. Students take the understanding that multiplying by 10 moves every digit one place to the left and apply it to multiplying powers of 10. Multiplying 6 times 10 4 times would move every digit 4 places to the left and would be represented as 6 times 10 to the 4th equals 60,000. 5 times 10 to the 3rd equals 5,000 because we are moving every digit 3 places to the left. This concept also includes decimals to thousandths. 4 and 58 hundredths times 10 to the 3rd equals 4,580. We are moving each value to the left 3 spaces or place values. Students will need to understand exponents and their relationship to multiplication. Exponents are repeated multiplication, just as multiplication is repeated addition. In the example 10 to the 3rd, the 10 is the base and the 3 is the exponent. The 3 identifies the power we are raising the 10 to. Although the exponent is sometimes referred to as the power, it is actually the product itself that is the power. When we write 2 to the 3rd power, we say the 2 is the base and the 3 is the exponent, and the whole thing is a power of 2, in particular, the 3rd power of 2. The awkwardness comes from the fact that we call this expression 2 to the 3rd power, or 2 raised to the power of 3. This sounds as if we were saying that 3 was the power to which we raised the 2, and as a result, the word power is often used interchangeably with exponent. But if you look closely at the phrase raised to the third power, you see that we are not just saying that 3 is the power, rather 3 identifies which power you are talking about, the third one. We are raising the 2 to a power, changing it from its original weak form to a more powerful form. In fact, we raised it to its third power, the third level it can reach. The power is the number it got to, not the number of steps it took to get there. Students in 5th grade also will be given examples to relate exponents to real-world contexts such as populations. They will discuss how numbers are written and how they are read aloud. Students may find numbers with a negative exponent to represent small numbers. Students are not introduced to negative integers until 6th grade and negative exponents until 8th grade. The objective for this lesson was to be able to understand the progression of place value in 5th grade. We met this objective by discussing how each year builds upon another to 5th grade, where students analyze patterns, powers of 10, and use decimals and exponents.